Hello and welcome to Chapter 4. Section 1, we're looking at ratios. This whole chapter is on ratios and rates and proportions. And so we're going to learn them all kind of separately, and then we're going to see how they kind of fit together. Okay? So a ratio is a comparison of two quantities by division, and it looks a lot like a fraction. For example, let's say I have a bag of marbles, and in my marbles I have 4 blue ones and 10 red ones and 8 green ones and 7 black ones. And my ratios, if I want to figure out what's my ratio of blue marbles to black marbles or red marbles to green marbles, that's the kind of thing. So if I'm asking for the ratio of blue to red, it's in the order that it's given. So you want to start with the blue one. It's going to be 4 to 10, which is the red one. Now, there's 3 ways to write ratios. You can write it to look like a fraction. You can write it with a colon, or you can write it with the word to, but you read them all the same. This is not 4/10. This is 4 to 10, 4 to 10, 4 to 10, okay? But you're not done there because you have to reduce them just like fractions. These are actually 2 to 5. The ratio of blue marbles to red marbles is 2 to 5, okay? In a lot of ways, they're going to react just like fractions. But there's a couple of exceptions. So don't just say, okay, we're working with fractions. Understand ratios are a little different, okay? So we're going to work with them just a little bit. So now in this same list, what's the ratio of black to blue and red? So my first number is going to be the black marbles, which is 7. But the second number is going to be whatever blue plus red is, which is going to be 4 plus 10. So this is really 7 to 14. And of course then I have to reduce that, simplify it, and that's 1 to 2. Another way to look at ratios, another question they might ask you is, what is the ratio of the green marbles to the total marbles? So that's green marbles to all of them, including the greens. Or they could say, what's the ratio of greens to all the other marbles, in which case you add everything but the greens up. So you really have to look at what the question is asking for you to be able to write down the right number. It's not hard. It's not hard. You just have to pay attention. Okay? All right. Warning. There are 2 ways that ratios are not like fractions. For example, if you simplify 4 to 2, you simplify it into 2 to 1. If you're a fraction, you just simplify it to 2. But this isn't 2 because you have to compare it to 2. You have to compare 2 things. That's what a ratio is. It's a comparison of 2 things. So if you take away the other number, you're not comparing anymore. So now it's just a number. You have to keep your ratio, okay? Also, when you simplify an improper fraction, it's this. It's not 1 3/4 because this doesn't compare 2 things either. You can't make a mixed number out of a ratio. It's 7 to 4 because this doesn't make any sense. If I'm saying how many purple marbles to orange marbles, 1 3/4 doesn't make any sense. Okay? So this is the 2 ways they're not like fractions at all. So this is how ratios differ. There's also a whole decimal thing. Okay, anyway, we'll get to that too. So what do ratios look like in word problems? And here are numbers that I completely made up. In Ashland Middle School, there are 252 students and 9 teachers. Write the ratio of teachers to students in simplest form. So it's teachers to students. So you're not going to just write down the numbers that you see because that's students to teachers. Please realize that you're going to do 252 to 9. And then you have to reduce it in its simplest terms. Does 9 go into 252? I don't remember. 2 is 18. 72 is 8. Yes! So it's actually 20. It's not 28. It's 28 to 1. That's your ratio of teachers. No, I did students to teachers. I told you not to do that. Darn it. And then we did it anyway. It's not teachers to students. And that reduces to 1 to 28. For every 28 students, there is 1 teacher. Teachers to students. All right, I'm glad I checked my work, because, man, I would have got that wrong. I hate getting things wrong. Okay. Is it your turn? It's a practice. We're not even your turning. All right. I'm just expecting you to be able to do this. Check this out. So, if you work for a photographer, you will know that these 4 sizes with this width and this length exist. Which picture has the greater ratio of width to length? So you're going to make fractions out of width to length. Now check this out. That means you're going to have a fraction with a decimal in it. That's weird. But that's ratios. And that's okay. It's only okay in ratios. Alright? What your job is going to be is to figure out which is the largest fraction, which means you're going to have 4 fractions, and you're going to have to find a common denominator to figure out which one's the biggest. Okay? So here's some more fraction work disguised as ratios. Problem number 2. In the soccer league, there are 25 5th graders, 36 graders, and 15 7th graders. Please write the ratio in all 3 forms simplified for, and here are the 3 ratios, 5th graders to 6th graders, 7th graders to total players, 5th and 6th graders to 7th graders. So you're going to write 3 ratios from these numbers. All right? That's your practice. So, good luck. Stars, hazard signs, questions. Have a good day.